Until 2004, Titan remained a great mystery to astronomers, as a dense, opaque haze prevented understanding of its surface. On 2004, the spacecraft Cassini reached Titan and released a small probe named Huygens. That would change everything. These are the images that the Huygens camera recorded as it descended through the haze. Titan's landscape is very similar to Earth's, with mountains, valleys, and plains. When the probe touched down on the surface, it revealed something no one expected. There were pebbles everywhere, similar to the rocks of riverbeds on Earth.
When you are looking at those pebbles, yes, they are rounded pebbles, and they have been rounded by torrents and rivers. But they are not rocks in the sense that we understand. They are actually water ice, so hard that it behaves like rock.
How were these rocks eroded? Is there liquid water on Titan's surface? At minus 180 degrees Celsius, water should be frozen solid. Cassini's radar had the answer. It showed us that Titan's surface has hundreds of lakes.
The big difference, though, is that they are not made of liquid water. They are made of liquid methane.
These two hydrocarbons on Earth are volatile gases. But with Titan's chilly temperatures, they are liquid.
The atmosphere of Titan has methane and ethane and other organic materials that provide a very different kind of chemistry, but a kind of chemistry that is reminiscent of what Earth very possibly looked like before life was abundant.
All these worlds are very far away from the heat of the sun, so they are extremely cold, and some of them are exposed to very high levels of radiation, as they have very thin atmospheres. Therefore, their environments are quite hostile to life. However, life might have found its way.
We also now know about extremophiles, forms of life that live in environmental conditions that when I was a student, I was told, impossible, can't have any life there. It's too hot, it's too cold, it's too acidic, it's too basic, too much pressure, too much radiation. They have evolved to thrive in those conditions. So this whole new field of study of extremophiles, it's a game changer. It changes what we think about the possibility for life somewhere else.
Extremophiles such as bacteria that live in high temperature, toxic, deep-sea hydrothermal volcanic vents on Earth offer insight into life that could have developed on other planets that mostly share such extreme, inhospitable environments, which also can include freezing temperatures and minimal sun exposure.
This gave us such a different view of actually what was necessary for life to survive. And all of a sudden, the solar system totally exploded. The horizon of what we call habitability and habitable environment completely expanded in ways that we could not have expected at all.
The chances of finding life on any of these remote worlds in the solar system are now much higher. Finding it is simply a matter of time.